Hi, everyone, and happy Friday. For all of you who thought you were going to get away without hearing one of my amazing jokes, you are wrong. Sorry. What does a cloud wear under his raincoat? Thunder pants. Hopefully, you all enjoy that joke. So, as you all know, I am quarantined. I will be quarantined through the second quarter, so I will not be returning before Christmas break. It'll be in January when I'll be back in person. I am feeling okay. I feel fine, so no need to worry about that right now. So since you will have a sub the rest of today and the rest of next week, please make sure we are respecting our sub. Please follow the directions that they are giving. It is important that you are doing what they ask, even though it might be different than what we would normally do if I was there. We're going to follow what they have asked. So please make sure you are doing that. We are going to continue to keep learning and doing math. So please make sure you are staying focused. With these recorded lessons, you can always pause them and or go back and rewatch things. So when you're filling out the guided notes, those are there to help you follow along with the video. So I do expect that you are filling out your guided notes. Our goals for today. I can write algebraic expressions by finding keywords. Let's have a positive attitude, and as always, choose kindness. Today's agenda will be, you should have already completed the weekly review number 10. We're going to get started on the lesson 1-3, writing algebraic expressions. And I'm sorry, but there is homework on a Friday. I know. It is Math Excel 1-3. It is not due on Sunday. It will be due the following Sunday. Let's go ahead and get started with our lesson here. Lesson 1-3, writing algebraic expressions. So this is similar to numerical expressions, but just this key word here, algebraic, means we are going to have variables inside of our expressions. Those are those unknown values, which we use letters. So you can write algebraic expressions to represent real life situations that have unknown values. So here in part 1, let's go ahead and break these word phrases down. It says a number plus 20. Our key word for this is plus and a number. If we do not know what a number is, we use the variable. So selecting our operation here, plus would be addition. So add. The algebraic expression, a number, we do not know what it is, so we can use a variable. I'm going to use the variable x plus 20. If you want to use C, if you want to use Y, any letter can be put in here to represent a number. All right, the next one, we have 20 times a number. Times is your key word to represent, yes, multiplication. Now, let's be really careful here. We have 20n. Remember we talk about how sometimes mathematicians were lazy? Well, in this case, they were lazy when writing 20n because 20n is 20 times n. So we can rewrite that if we want as 20 times n. But again, they felt lazy and felt like we did not need this dot here, so they are combined together, but that does mean multiplication. That's really important. Okay, the next one, we have the difference of a number and 20. So the key word for the operation is difference, which will represent subtraction. All right, now let's write the algebraic expression, the difference of a number and 20. So a number, we do not know what it is, so we're going to use, yes, a variable. How about we use y and 20, so minus 20. Remember, order matters when you are subtracting, so we have to write it as it is written in here. So the difference of a number and 20 is going to be the number and 20, so in that order. All right, the last one, we have 20 divided by a number. So again, keyword. And this one would be 20, or 20 divided by, I'm sorry, divided would be your keyword for the operation. That's how you get division. A couple different ways you can write division. That would be 20 divided by a number. So let's use, how about C? Or we could write it as a fraction. Remember, fractions are division problems. So 20 over C is another way to write it. Okay, you have 3 problems here. Why don't you go ahead and give those a shot on your own? Okay, what is the algebraic expression for 18 more than A? Keyword for the operation is more than. So it says 18 more than A, so that means we need to start at A and we add 18 to it. This is one of those word phrases where it goes the opposite way. So it should be A plus 18. Even though order does not matter when you are adding, in this case, when it gives it to us written in a word phrase, we do need to write it in the way that it's represented in the word phrase. So it should be A plus 18. All right, the next one. What is the algebraic expression for the product of 13 and a number? Keyword is product. Product means, yes, the answer to a multiplication problem. So we do need to multiply, and we're going to multiply the numbers in the order that they are written. So you should be writing 13. I'm going to use, I don't know what a number is, so I use the variable. I'm going to use x. This is the way you will see it written most often, is just 13x. If you wrote 13 dot x, that's correct, but we don't write it very much like this because we're lazy and they can just put them next to each other. All right, the last one. What is the algebraic expression if you had 8 Jolly Ranchers and you ate some number of them at lunch? Okay, if you eat something, you're taking that away, so we should have a subtraction problem here. So the first number is what you start with. We are going to start with 8 Jolly Ranchers. And then we are taking away some amount. We don't know what that amount is, so that's our variable, J. I don't really know how many Jolly Ranchers you could eat during lunch, but it can't be very many. All right, as I stated earlier, you can use any letter to represent an unknown quantity. There are some letters that you probably shouldn't use. One of them would be an L. Why would we use an L? Yes, it looks like the number 1. If you have L plus 2, that just looks like 1 plus 2. Another one some people don't like to use would be a T, because that could look like an addition sign. So again, some of the most common ones you'll see are X, N, Y. You can use any one you want, but make sure it does not look like a number or a symbol. But if it gives you a variable in the problem, you have to use the one that's given to you. Okay, a state park has 3 lakes. In the spring, each lake was stocked with the same number of fish. What algebraic expression represents the total number of fish in the lakes? So with this word problem, what do you think the algebraic expression would be? Go ahead and try to solve that on your own. So if each lake is stocked with the same number of fish, but we do not know how many fish are in each lake, we can use a variable to represent the number of fish in each lake. So I'm going to put an F here. There are some number of fish in this lake. How many fish would be in this lake? Well, it says that each lake was stocked with the same number of fish. We don't know how many it is, but we do know it's going to be the same as lake number 1. So we just use an F. If F is 10 here, it's going to be 10 in this lake. Then the third one should also be an F. So the algebraic expression for the number of fish in all the lakes would be, you could say F plus F plus F, or we can make that into, that's repeated addition, so multiplication. So 3F would be your algebraic expression for the number of fish in the lakes. Okay, let's go to the next problem here. It says Spring Lake is 3 miles shorter than Grand Lake. Write an expression that represents the length of Spring Lake, where G is the length of Grand Lake. So some important things in this question, they've given us the variable that we have to use. So we have to use the variable G. We have Spring Lake, and it is 3 miles shorter than Grand Lake. Okay, so we do not know the length of Spring Lake, but we do know that it is 3 miles shorter than Grand Lake. So to figure out Spring Lake, you have to start on the distance of Grand Lake. And G represents Grand Lake. So we start with G. Spring Lake is 3 miles shorter than Grand Lake, so we're going to minus 3. So in the problem, G represents Grand Lake, and we are going to subtract 3 to get the distance of Spring Lake. So far, we've been dealing with just one operation with our algebraic expressions. We're now going to move into 2 operations while writing algebraic expressions. So our first one, we have the quotient of 20 and 4 plus 6. So our 2 key words for operations are quotient and plus. So that means we're going to use division and addition within one algebraic expression, or this would be a numerical expression, I'm sorry. So the quotient of 20 and 4 plus 6, so we would have 20 and 4, so 20 divided by 4 plus 6. Right? Then we have 4 less than the product of 5 and 6. Again, a numerical expression because we have all numbers. Keywords are less than and product. Remember the key thing about less than. It gets put on the very end. So in this problem, you have to start 5. Product is answer to a multiplication problem, so 5 times 6 minus 4. A lot of people like to put parentheses here. You can, but you do not have to. If you want to put the parentheses there, to make sure that you do that first, because it's the product of 5 and 6 for less than that. So you can, but you know that the order of operations that multiplication comes before subtraction. So either way, with or without parentheses works. Now I would like for you to try these algebraic expressions. So take a moment to go ahead and write the algebraic expressions for these two. Let's go ahead and go over them now. C less than the quotient of 10 and 5. Keywords, less than and quotient. So we should have subtraction and division. Yes, I know you were all thinking it. Less than. Key right there, we know that's going to go at the very end. So it's C less than the quotient of 10 and 5. So 10 divided by 5 minus C. So you have to do the quotient of 10 and 5 first, then subtract C away from it. Next one, the product of x and 7 minus 4. We have product and minus. Those are our two keywords for the operations. So we're going to have x times 7 minus 4. Again, you can leave it just like this, or if you do want to put the parentheses in, that's okay. It does not bother me. Now you're ready for some word problems with writing algebraic expressions. Yes, I know you are all so excited for this. So, a store charges $15 for a shirt, plus $2 for each letter that it is put on it. So, if you have 2 letters, you would put $4 extra, right? $2 for one letter, $2 for the next letter. Write an algebraic expression to represent the total cost of the shirt. So some of our key information here is they charge $15 for a shirt plus $2 for each letter they put on it. What is always going to stay the same here for no matter what? Yes, that is $15. We are always going to pay $15 for a shirt. No matter what your name is, you're paying $15 for that shirt. Then we are going to plus, so we add $2 for each letter. So for each letter, it's $2. Again, like I said earlier, if there's 2 letters, it's 2 plus 2. Or if there's 3 letters, it's 2 plus 2 plus 2. That's repeated addition. Repeated addition is multiplication. So we can use 2 times some number we don't know. Let's use n. Okay, $15 for your shirt plus $2 for each letter that you put on it. That would be your algebraic expression for this word problem. Why don't you go ahead and read through these 2 questions and try to solve them on your own, and then I will go over the answers. So you should have given these 2 a shot on your own. If you have not, please pause and make sure you're trying it on your own. All right, a national park charges $25 per bus and $12 per person for a tour group. Write an algebraic expression to represent the total cost for a one-day tour with 1 bus, and let n represent the number of people. Let's go ahead and underline our important information. So it's $25 per bus and $12 per person for a tour group. We want to find the total cost for a one-day tour, 1 bus, and let n represent the number of people. So again, we have to use the variable n. All right, so we know it's a one-day tour and 1 bus. So the cost for the bus is going to be $25. Now, do we know how many people fit on this bus? Nope. Do we know how many people are going on the bus? No. But we do know it costs $12 per person. So that's going to be plus 12 times n. So 25 represents the cost for the bus for one day. And the 12n is the $12 per person. So $12 times your variable n that was given to us that represents the number of people. So this is your algebraic expression. All right, the next one, the same national park charges $26 per adult and $16 per child to raft on one of their two rivers. Write an algebraic expression for the total cost of adults A, so there's our variable we have to use for adults, and child C, there's our variable for child, to raft on one river. So $26 per adult. Do we know how many adults are going? No. So we can use the variable A to represent some number of adults. So 26 times A is going to represent how much it costs for adults. This word and here, that's a key word for addition. Then $16 is the cost for a child to go on the raft. We don't know how many children are going, so again, we're going to use the variable C. That is the algebraic expression for this word problem. At the end here, I want to go over some review of 1.2, some vocabulary terms, and some examples. So we have a variable. A variable is a letter that represents an unknown value, which in this case, we can use any letter unless it tells us which letter to use. We use these variables or letters to put in any number. So when a word problem gives us a problem, but they say we don't know how people are going, you just use a variable so that we can plug in any number and then we can solve for it, which we will do later on. But again, a variable represents an unknown value. The next one we have is term. So a term, a number, a variable, or a product of a number and one or more variables. Here is what I think is the most important part. Separated by a plus or a minus sign, as long as the plus and minus sign are outside the parentheses. Okay. Separated by a plus or minus sign. You do not separate them if they're inside of the parentheses with a plus or minus. Lastly, we have constant. Constant is a term that contains only numbers. Okay, so it's just inside of a term, it is just a number. So 15, 12, anything, as long as it does not have a variable with it or another operation. Lastly, we have coefficient, the number part of a term with variables. So a coefficient is the number in front of a variable. So if we have 5x, the coefficient is 5. If we have n, the coefficient is 1. Remember, if it's just a variable, the coefficient will always be 1. Okay, let's go over this example here. Algebraic expression, because we have variables or letters. Let's first talk about how many terms are in this problem. I see a minus sign here, a plus sign here, and a minus sign here. We are not including this plus sign because it is inside parentheses. I'm not including this multiplication sign because it has to be a plus or a minus sign. So the number of terms that I have are 1, 2, 3, and 4. There are 3 plus and minus signs outside of parentheses, so that's going to give you 4 different terms. All right, the next one is a coefficient. Our coefficient is the number in front of a variable. So in this case, 4 is the coefficient to c, and what is the coefficient of x? Yes, you said 1. You are correct. Okay, that is a 1x. We just get lazy with it. All right, and we then have a constant. The constant is just a number. So in this case, the one that's just a number and a term by itself is 12. So 12 is the constant. For c is not a constant because we don't know what c is. There's that variable there. 14 times 5 is not a constant because there is another operation. This is not a constant because we have a variable. So 12 would be our constant.